Hello, my name is Sushma and I'm submitting this project for the module 2, which is managing machine learning projects. Today, I'm going to talk about a specific problem statement which is related to my area of work, which is the tax industry, and how people take have to struggle to finish off their tax returns, specifically given that it's a self-prepared tax return. This specific assignment is to deal with how machine learning could help to solve for this specific pain point. So, is there a problem? Yes. And I will walk through the three criterias about: is there a problem, can machine learning solve, and does anybody care about it? The problem statement is: as a taxpayer, I'm confused as to what types of deductions or exemptions that I, as a taxpayer, am eligible for. This makes me go through scores of web pages to understand if I am eligible for any specific deduction and how do I calculate those deductions. It makes me feel very frustrated and very confused with all the taxonomy, all the descriptions and terminologies that are being used. It ends up making me feel frustrated and overwhelmed. So yes, there is a specific problem that we are trying to solve for. Let's take an example of the US, where the tax laws are pretty much very complex and it needs a lot of subject matter knowledge to prepare for these returns. There are close to 168 million tax preparers, and roughly 51% of them do self preparation of their tax returns. On an average, it takes about 11 to 12 hours to prepare a tax return for each individual return. So just imagine 168 million, roughly 51%, and 11 to 12 hours for each tax return. How can ML solve for it? Based on the concept of people like me, like people who have filed tax returns who are similar to my age, my profession, my kind of deductions, my kind of a family structure, or my kind of eligibility, if ML can help score through or walk through millions of data and provide suggestions as to what I'm eligible for, what are the suggestions that could be enabled for the taxpayer to go look for the specific kind of deductions that they may or may not be aware of, it can be very well solved with machine learning. So let's go through the CRISP DM process of defining the problem. So the problem statement here is for the individual taxpayers who's trying to self-prepare the tax return. The problem statement is that as a taxpayer, I'm not very sure about what deductions or eligibility that I have in terms of my income and exemptions. Why it matters? Because tax preparation is a very engrossed activity in an individual life, and it gets very overwhelming. Right now it is being very solved very mechanically, unless and until I have a tax preparer who is on my side guiding me through the process. It can be very overwhelming. So there's definitely a gap in it. How do I measure success of this particular ML model? Could be based on a couple of things. It could be directly proportional to the hours that is saved by an individual taxpayers based on the suggestions that they have gotten. It could also be measured by the accuracy of the suggestions that has been given and how the users react to it. And the outcome could be measured with the precision with which the tax return or the tax amount has been calculated. The output could be a classification error metric based on 1 to 5 scale of accuracy, depending on what kind of classification of tax eligibilities or tax exemptions that the ML model has calculated. It can also use a regression metrics to ensure that the error with which the model is working falls within the acceptable limits and whatnot. How would we validate the specific model? It could learn from millions of data that is already available. Of course, the commercial library will need to be used because it is tax laws and the tax data which is privacy protected. So the ML would be using that. The recommended approaches, it could go through a recommended approaches model where it could suggest what kind of users will be using this specific model. To experimentation, we could experiment with the ease of use, the simplicity of the use, the acceptance of the suggestions by the users, and whether they are going through what kind of deductions that the model has proposed, and if it has been any different for them. For the ML system design, I would suggest that this has to be an edge. It has to be an edge technology because of the privacy of the tax laws. The latency has to be extremely low because of the need for faster responses, and it has to be on the user's device. It could be like on a web page or on the user's device. Between the offline and the online learning models, it could be an offline learning model because it can work on a scheduled model training, because based on tax data that come in for a week, the model could retrain, and based on that it could give out new suggestions and whatnot. Between the batch and the online prediction, this specific system will have to be an online prediction because the users will need faster responses. The risk is based on the training data, there could be a training serving skew because depending on the tax laws and the people who are going to be using it, the training model could be based on a specific set of users, and hence we will have to take care of the training skew. There could be a content drift because the intent of using the ML for a specific persona or a profile of users could be crept in with a different set of users who might be using that particular model. There could be a data drift because there could be features that might change while the preparation of the model. So these risks are something that we will have to keep in mind while designing this model.